Really? Yeah. I saw the town about too. That's really great. It's also okay, so it's good parents. I actually don't know if my dad is this much. It's stock in other years, but I don't know if they can about it. It should have a good year. So it might be. It's a great concept.
All right, cool. So goal for today is wrap up any lingering questions with project 4. Friday I'll be here, but if you turn in project 4 and you're like done, you want to head home for Thanksgiving, that's fine. We'll be back after Thanksgiving. We can either, and it's all connected. So if you have questions on module 1, like you're trying to go back and revise things, it's only going to help anybody working on module 5 because it's all the same kind of stuff. And hopefully what you've noticed is that if you've just been consistently kind of chipping away at these assignments, if you go back and try to redo homework 1, a lot of it is going to feel a lot easier because you have a lot more experience. You know better ways of doing things, like all this thoughts of like linear algebra and data processing. It's all connected. Like you can do things a lot faster in those first assignments. So anyway, that's the plan for finishing out the semester. And it's like we're here. We're like basically done. Cool. So what do we have for module 4 project or any other questions that might be the topic on top of your head we're working on? Yeah.
For the bonus module, could you do one and not the other?
You can do any mix of them. Some people have like started module 5, run out of time, and just turned in like 3 problems. It's like, okay, well, here's an extra 10 points or something, like. So like usually end of the semester, at least this is how it works for some people. It's like, I'm gonna do so much stuff at the end of this. I'm gonna like be on top of everything, and then you start studying and you realize like I have 20 minutes to study for every final until I start doing this, and then this project that was supposed to take me an hour is taking me 24 hours. So some people get started, all they can do is just like a little bit, so it's still just, it's bonus points regardless, so as much or as little as you want to do.
And the homework one will go along with the homework side of the grading and the harder to go with the final side of grading?
Yeah, yep, okay. Yeah.
Yep. Boost, okay.
Yeah, if you're trying to boost either score. Yep. It's all points at the end of the day. Yeah. Anything else? Any other questions that are coming up for now? I'll check in and see what kind of demos or troubleshooting we can go through next. I'll be there for the second half. I have like, I think 6 posters. Yeah.
Oh, you're gonna assign that group?
Yeah. Everybody has. I was like Professor Marino, Professor Barber.
Do we know those versions?
Maybe. I don't know. I think we know, but I couldn't even tell you. I haven't
And then, I just thought it was all right. I didn't, outside of the first one I got was the trigger. It's a lot more interactive than before.
Yes. Yeah.
So it's a good team like presenting different people actually with the afterwards somebody like a team or somebody else.
Yeah.
I think that's really good.
Yeah. It is really good. Yeah. And it's good practice for, because it's exactly how a demo tape goes. A lot of people and like divide between small parts.
Oh, I see.
And it's not just a scripted.
Yeah, it's kind of on the spot.
Yeah. Are you printing it now?
No, I'm sure getting it. I have to. That'd be pretty good.
Really. Oh, it does say that. It does just say that. I mean, you could always say more than this, right? So as long as the area is bigger than yeah, but that's true. It doesn't say or equal. Yeah, that was there. I just don't agree with it. And that is you because it's under constraint. Trying to solve the problem. Yeah, but there's also
I don't know if the conference will be, so the first thing it's gonna be class. It could be like this. But like, it's supposed to flow. Oh, you're gonna have to get a picture of it. Like, why? You're like somebody who wants to just talk about. I couldn't get into robotics. Pretty sure it's earth science. Because I did earth science, I think my friend's like, he's actually taking it right now. I signed up for it and we did the first one too, so that's contingency. They actually did another one last week, but it was hard. If he's an earth science major. He just said you have to memorize the source and stuff, not like specific measures. But it's even better. You also higher oh, okay. Yeah. One is the fall for like after college. Okay. And then oh, so you did it. So you only did it. This was cool. Oh, wow. Like it doesn't give us any like real information. Yeah, it's something that you know is the actual start. Because it's the next semester it's all for why then solve around that. And that one you have not translations. The rest is politics because that's jumping in some data right it's lost on and this thing is two which following the actually done one with the best of them. You already did. Yeah, when you said LU, yeah, that was it. This is if it features like all This is blurry.
Yeah, because it's a matrix, so really you're doing if you're doing by hand, you can first let out. We solve the problem. L comma F with the data. Solve the problem. U comma Y. A bunch of zeros, so it's 11 zeros with one value of negative. Usually what I use is create zeros, create 11 zeros, and then plug in F bracket 5 and dollars negative 300, and then some reset. Now I know everything is zeros at that spot. And I can walk this process. Usually this question yeah. The link is in there at all times. Yeah. Oh, M, sorry. Okay. Yeah, sorry. All right, let's do some troubleshooting. All right, so we're gonna take this linear algebra big KU equals F, split it up into like lower and upper equals F, just the applied forces, and then find like all the free node displacements. Yeah, so we'll leave this. I'm gonna import that LU function. You can use LU naive because this is a pretty, we don't need to do any pivoting to solve this problem. It's like well behaved. Gauss elimination works pretty well. So when I get that LU decomposition of that 2 through 13, so just what I'm doing here is defining a problem that is just the stiffness of nodes that can move. So I'm ignoring all the nodes that have boundary conditions. And I can see that first matrix is an 11 by 11 identity matrix. It's all ones along that diagonal. So it's not pivoting. It's not rearranging my equations at all. And then the next matrix is 11 by 11 lower, and then 11 by 11 upper. Kind of got our uppers and downers. So P, L, and U are going to be LU of that K. And one way that I could do this is go back into the reading in this Gauss elimination. I think it's LU. Is it LU underscore? No. Or is it solve? Solve LU. There we go. So I could grab this and just give it LU and then F over EA. I could use this like solve LU code. Equally as valid is, I could say linalg solve of L and F over E over A. And then U is, I'm going to call it U free. And I also need to define F. I know I need 11 zeros, and I want that fifth one to be negative 300. So I have a vector that is the right size. It's one-dimensional vector, 11 with 11 things in it. Only one of them is negative 300. And then I get this answer that all my displacements, at least all the things that can move, are these displacements. And the way we kind of split it up for finite elements is like, this is U2x, U2y, U3x, U3y, and then U4x, U4y. So node 4 is where we're applying that 300 newtons. Makes sense that that's the biggest number, like negative 16 millimeters, because that's where the force is actually applied. So overall, seems like we're doing something right. But now I want to figure out what the reaction forces are. So I set up the problem. I knew the stiffness of my structure based on its modulus and area. I want to figure out how much force there is on every node. All of the displacements, if I want to say these were the displacements of everything, I have 3 degrees of freedom that I already defined, and they were 0. So I'll say that this is zeros of 14, but 2 through 13 are U free. That's why I'm using like a different variable for U, so I'm not using the same thing. So my total displacement vector U is zeros, and the middle 11 are those solutions that I just solved. So now I have everything, U1x, U1y, U2x, U2y, all the way up to U7, displacement of node 7. It moved to the right 6.5 millimeters, but it moved down 0. had 0 displacement. Oh, and I already used, oh my god, I did this last time too. I'm going to call this like F applied. It's not going to change my output at all, but it's just going to give me a new variable. So I can say F is E times A times, now K is the full 14 by 14 stiffness matrix. Every single one of those displacements times, like the actual at symbol to say do matrix multiplication, times U. And let's do a comparison. This was my F applied, so 11 zeros with 1 300 in the middle. Now I'm also solving for what were the reaction forces at node 1. So there was basically 0 on in the x direction because I had no applied x force. So it makes sense that my total x force is 0. 150 newtons up in the y direction. Again, good, because it should be F over 2 pointing up. And then a bunch of zeros, all those negative 14, negative 15, it's all just zeros stacked up with some floating, some round off errors. Negative 300 applied, and then finally that last node 7y has a 150 up. So it looks like things are good. All is good in the finite element world solution. So I have all that. Now I want to see what this looks like. Maybe I want all the vectors of forces. I want those node, like all the node displacements drawn as little arrows to say like how far did everything go. In that extra FEA material, which everyone, depending on what link you use, it might bring you to a 404 not found. It is exactly where it says it is. It's just we need to do that same .md, like add md to the end. Sorry about that. M is in Nancy. Oh, why did I do that? And then it loads up. Let's do a quick restart run all, because at the bottom, yeah, down here, this is the same structure that we're dealing with, this last function. If you want an interactive plot, you can grab this whole, that whole cell, and then you could kind of look at, all right, what does my applied load look like? So we could grab this whole thing, right? See how it works. And I'm gonna do a kernel restart run all just to erase anything that came up. Yeah, so that's what I was looking for. So it's telling me R is not defined because I didn't, and nowhere in my code have I said R equals something. So let's do some troubleshooting. Let's go find R. Coming up. Keep going. Here we go. So R is going to be all the points that I want to plot of the undeformed structure, all those XY spots. So let's grab that IX and IY and R, and we'll throw that right in here, right below. So now I've got R. Then I try to run again, and it tells me L is not defined. Oh, but nodes was defined. Okay. and L is 300 or 0.3. So L is going to be 300 millimeters. So each one of my bars is 300 millimeters long. Now I've got this solution here, or I can scale it and take a look at what happens as I go from like 0 to whatever 10 times that displacement. So usually the nodes, usually that's the other problem that we get. Let's get rid of this one. Yeah, so now I'm getting this nodes is not defined. And I can come back up and say, all right, well, where was nodes defined? And that one's right in here. And what nodes is defining is there are seven nodes to define like each of these 11 elements, and a lot of them share nodes, like how they're connected. And this is, you don't need this information to like get through the project, but this is exactly how like ANSYS and other finite element programs work. They define a whole bunch of nodes, like the actual, what are the locations in space where things need to be connected. And then the element array tells you how each element is built. So like element 1 and element 2 both share node 2. And then if we look down the list, node 4 is also connected to node number 2. Because all these are like triangle trusses, so it makes sense that every node is going to have like 2 or 3 elements connected to it. So there's the node array and the element connectivity array. It's like the background, pulling the curtain back from the FEA process. At least if you want to do the same, if you want this same exact like post-processing, like, is the code working? It's like, yeah, it seems to be working. Or if you want to throw a wrench into things, we could say, what happens if F applied 4 is 100? Add an extra 100 Newton force in there. So now it really starts moving to the right because we have that applied force that's not only down but off to the right. Then we get reaction forces, like big reaction force here and nothing there. Not really part of the project, but it's still fun. Yeah, and that's like, these are the pieces that I needed to copy and get it to work. Different? Yes. Okay, that one will show you structure. That's that one. One that I just grabbed that the very last field. Yeah, if you want it to be interactive with the whole thing. Yeah.
I was like,
I didn't even try.
Yeah, and this one structure is showing you
I got both of those.
what is the
Yeah, usually I think usually that's the thing about their yeah, I think the beers are right. Yeah. So we just
yeah, yeah, and we'll just try again.
and I think the final like the profile a little bit, but I really hard to kind of like the single
I heard that people take this one class before. Yeah, they said they were better on it. But I can just be because they knew they were going to get right. So, I don't know. You want to read it out. I feel like that is. If you did both of those, that's 20%.
But that would be if you had those first 3 lines in the last.
Yeah. Yeah. So, yeah. The second one did. The first one.
Oh, that's the first one. I didn't even like the second one.
Yeah. I would try to say that. I would say it's both pieces.
Yeah.
I thought I was at. Did you just not show as much of your work? Because that was the thing. Like, I don't know why it says when you have the page, but then it take points away from the doesn't. I got the class. Yeah. I'm not sure. Yeah, I think you did post the solutions. I mean, I don't know, did you plug in others or you just I think you're supposed to just do formulate like what it would be in each. Can I ask like the question that you had because the young last time? Yeah. Can I ask that question? Yeah. I was like, oh, this answer makes sense. Yeah, no, I was probably confused going into it, like this was just play the numbers. Or am I supposed to actually like prove like the numbers up? So yeah, I put in numbers and then I also grew that. Yeah, it was all positive, right? Yeah. So yeah. It should be obviously like if you're and I'll show you yeah, very.
I started it and I don't know, man, it's tough. Yeah. And I get questions like it's one, but it's like 3 parts. And the first part is as long as an overall word. Yeah. It's got simulate the yeah, this is like dude, also like I've never had this like where they've never taken any points off. Yeah. 19 points off the board part. Alright, this is a little
numbers.
yeah, you need a third column because you have 1, 2, 3.
I also was never gonna like argue it because like you guys know that I'm a fan. Like he's gonna pick something out of it. Like even if it's small.
Yeah. Dude, my plan is to just memorize all the old files. Yeah, I think so it's not winter. It's fine.
Looking for the winter, I like tried that for a little bit. It was so hard to understand. I just kind of went
So
through
it. Dude, I can't read stuff. What I did was I took his exam questions in the chat.
Yeah.
And then I like use those solutions to study. I just memorize how to do each one.
Yeah.
And that took like probably a full day, maybe like 12 hours of studying, but
You do well.
yeah.
Classes, what grade? I think back in like 3.5 years.
Yeah, dude, I got like a C plus in one of those, dude. It was rough in the class. Like, dude, all my classes in API and A's, except the fucking Calc 2. Like, did I take Calc 2 with you? No, it was Calc 1 and she didn't. Dude, did I ever tell you I almost went to a concert with that dude? He was Miggy. Dude, I was talking to him about like the bands he liked. There's a show. I was like, no, dude, I'm gonna be going to this. He's like, dude, like I have a ticket too, but he didn't work out. Yeah, that's a very popular movie. That was a good story.
This is what I have to do. So this is extra work, but this is what I have to do to get this in there. For this, for the first challenge problem. Like I had to get so much shit in there. Just because it sounds like.
Maybe half grade.
So this is my other one.
Well, the third column is just zero.
Yeah.
Do you go to lectures?
Yeah.
So, did you like see, were you there for lecture where you were doing the like matrix stuff to find the
Yeah.
Okay. Because like I do do that for homework and I was like trying to figure it out.
Yeah.
I was trying to figure it out like after.
Yeah.
Because like I'm not sure you take the whole class before or after like we're doing like
It's a little bit confusing. I mean, yeah. Some of it, I usually figure out what I'm doing.
yeah.
I'm going to the church.
The worst part is our homeworks.
Yeah.
Like, that's like the worst part is that I'm gonna get a C and I'll get a B.
Yeah.
Like, what am I gonna do?
Yeah, it's just kind of ridiculous tax on it too, because it's 30% of the
Yeah.
40% and then 30%, and then with the home percent.
It's a little different. I think so. Dude, like for me, I think if I don't like fail them, they're fine. I'll go.
Yeah. I think in this, but
Especially if you're using the curve.
yeah. But that was only bad because I guess it's higher than the rate already is.
Dude, I like did it right, but the graphs were like complex and they didn't take any lights off. It's like
It's so weird how they graded it because with the last one, my signaling section, I submitted that was very close to the deadline. So the signaling part, I just like I very didn't like I got the right stuff, but the second graph was not clear at all.
I don't do simulate with the I don't know how we do it.
Like you know,
So
like
you know how
base.
yeah, you know how we like using like the equation. Dude, no, I use the integrator blocks.
Yeah.
Or I make the equation with the blocks. Yeah. And dude, I don't know, it makes a lot more sense to me. It looks wildly different.
That's the same thing as you. That's the same thing as me because like when I picked one, that one
think it depends,
A
like,
little bit movie thing.
but I think it's like how the class in general was on it. Like if all of the simulates are kind of shitty, then it's just gonna say like very fun. So I think on that one, it was much harder to get away. So not bad.
I feel like this is like what my like simulating look like. It was nothing like this.
Yeah, that's so much more simple.
Yeah, it's so much easier. That's what it's like. It's like the same effects.
That's when he said on mine was 50 points.
And validation.
Yeah. Yeah, validation.
I got it.
50 points.
Like the last one was exactly that. Like I feel I should have said more stuff, but I didn't. And then he was getting the points. I just couldn't do it because I didn't have enough time.
Yeah.
Needed to submit it.
For me, I just worked on it for so long. I did full validation on that one. It's just stuck in the video. I was gonna get another video.
Yeah, it's not as bad. Just picking up the weird is ridiculous. Like, even if the answers are wrong, they're showing it wouldn't. Yeah. Yeah.
Especially for platform works, it's funny to do that. It's funny to do.
Yeah. Dude, this is the whole code that I use for like the whole thing.
Yeah, I tried to do a transformation.
It doesn't work. No, I just like I literally put in that block with K and block to see that block there.
Well, no, you do, but you still do for it.
Oh, I see him on there with like equations in a block. Like I don't even know how to do that.
I did the equation, I did the blocks and so when I did that,
Oh, you're gonna dig.
yeah. And then, and some of them just turned red.
Also, if you like ask Chad how to do it, this is like one of them. Like it gives you like this kind of like I go on YouTube, I like watching the video you guys going on there, listen to like tutorials. They'll do it. Dude, I try to not watch it because my graphs are up. My graphs are up. I want to do like comic chat. I like comic chat.
Yeah, like this one, you're supposed to be able to see, like, at least in that picture, you can see, like, the phases kind of line up. This one, you can't even see the phase at all. You just get it, like, I don't know why. Like,
I think it's fine to look at it and make it pretty good.
yeah. You literally can't even see it.
I'm telling you, he looked at mine, he's like, you do this in the page.
It's just,
I'm sure that's wrong.
but he did say, like, he doesn't actually look through the whole, like, he just looks at the answer. He doesn't look through that. So he doesn't do this much partial credit. He just kind of,
I thought he comes out for that answers are over.
yeah. It's so weird. Like, why would you do that? You need to get partial credit. It's engineering.
Cool. Thanks for joining. Yeah, last thing that kind of came up, and I'll just put this on. You don't have to stick around while I'm working through it. Oh boy. Is just figuring out that cross-sectional area. So we're trying to figure out, I know right now my deflections are all 16.1 or less. So I'm trying to get that U, oh yeah, 5 plus 2. I want that U5 to be less than 16, less than 0.2. So I can come back up here, grab just that code that was creating U. Let's grab both of these. I'm going to join these two, merge them. So if I want that to be 0.2 or less than that, then this thing has to be at least 16 times bigger, or 16 over 0.2. Thanks a lot. So if I take the displacement that I had found before and multiply it by the ratio of my current displacement over that desired, it's one way of solving this linear algebra problem. And I can get closer if I wanted to. So with the area for steel 8 millimeters squared, and then my deflection 0.2, or I could probably get a little bit better than that. Take that 16.215, right? So 8.06 and then 0.2 millimeter deflection. Looking pretty good. And I can do that because I'm setting up this problem where F over EA equals K times U. So the bigger A gets, the lower U gets. Like it's in every term since they're all the same. And linear algebra, if finite elements is all linear, then it all works out like this, that 10 times the force, 10 times the displacement, 10 times the area, 10 times less displacement. Pretty cool. All right, thanks a lot. See you next time.